Hello class, Mr. Hansen here. Today we're going to look at a couple application problems of quadratic functions, and I'm going to start with example 1 in your book. I'll read it aloud and then we'll look at it on a piece of paper here. It says Abe Biggs wants to plant a flower bed in a triangular area in a corner of his garden. One leg of the right triangular flower bed will be 2 meters shorter than the other leg, and he wants the bed to have an area of 24 square meters. Let's find the lengths of the two legs. So if you look at the picture here, and I'll reproduce this on the paper, but this leg, remember the legs are the two shorter sides of a right triangle. This one is x minus 2, and this one is x because he wants one leg to be 2 meters shorter than the other. Okay? So let's see if we can figure out the solution to this problem. Alright, so I'm just going to sketch another picture of the same scenario. Alright, so here's our right triangle. Okay, and they had in the picture, this side is x minus 2. We obviously have a right angle, and this side is x. So this leg is 2 meters less than that leg. And we want to find the area. Well, you have to think back to what the area of a triangle formula is, and we have not used this in a while. So let me refresh your memory. The area of a triangle is equal to 1/2 the base times the height. So in this problem, this length would be our base, and the height is always the perpendicular height to the base. So this would be our height. So this is our height, and x is equal to our base. So if we plug and chug, we will get 1/2 x, which is our base, times the quantity of x minus 2, which is our height. And there would be our area in terms of this scenario. And if you remember, they want an area of 24 square meters. So we're going to put 24 in for the area. So now you can see we have an equation we can solve for. Now remember, when you're doing quadratics, you want to set everything equal to 0. Alright, so let's do this. Let's multiply both sides by 2, and that'll get rid of those 2's. And then what do I do to one side, I got to do to the other. So we get 48 equals x times the quantity of x minus 2. Alright, now let's distribute the x. So we get 48 equals x squared minus 2x. And then again, now we want to set everything equal to 0 and put our quadratic in standard form. So that would be 0 equals x squared minus 2x. And if I move the 48 to the other side, I got to subtract 48. Okay? Notice, it's a quadratic equation, so you should always think factor first. So remember, look for a GCF first. Does anyone see a GCF? I don't either. So now let's try reverse FOIL. Alright, the factors of 48 are 1 and 48, 2 and 24, let's see, 3 and 16, alright, 4 and 12, 6 and 8, and I think we found the pair that add or subtract to the absolute value of negative 2. Okay, so let's try 6 and 8. Okay, now we just have to figure out the signs. Well, it multiplies to a negative when we do last, so they got to be two different signs, but they add to a negative. So let's put the bigger number at negative, smaller number at positive, and I think we're good to go. Okay, so then, remember, we're not done. We factored the polynomial, but now we have to use that zero product property that says if I have two things multiplied together and their product is 0, one of those or both of those factors have to equal 0. So we're going to set every factor equal to 0 and solve. So x is either negative 6 or x minus 8 equals 0. Add 8 to both sides. We have two possible answers. But remember, this is a story problem, right? Remember our problem, we want to figure out the dimensions, these legs. So can we have a negative number for a length of a triangle? of a side? No. So this, just because of the context of the problem, this solution is thrown out. Okay, so it looks like x equals 8 would work. Let's see if it works out. So if x is 8, this would be 8 and this would be 6. Okay, so if we try to find the area, remember the area should be 24. Area is 1/2 base, which is 8 times the height of 6. Okay, half of 8. A lot of people make mistakes. Just take half of the first number, not half of both numbers. We're not distributing the half. Half of 8 is 4. 4 times 6, sure enough, is 24 square meters. Okay, so this would be labeled meters and this would be meters. Alright, so a good application of a quadratic equation. Alright, let's look at another example in your book. This is example 2 on page 443, excuse me. Alright, it says the product of the second and third of 3 consecutive integers is 2 more than 7 times the first integer. Find the integers. So this is one of those problems where we got to define some let statements. Okay, let's do that. We're going to let x equal the first number. And I'm going to abbreviate here. So we want 3 consecutive numbers. Well, if x is the first number, what's the next consecutive number? That's 1 more than that, right? So x plus 1 equals the second consecutive number. Okay, and then if our first number is x, our next number is x plus 1, the third consecutive would have to be x plus 2, right? So third consecutive number. All right, now the problem said the product of the second and third. Okay, so what does product mean? Product means multiplying, right? So we got to take the product of those two. So the product of the second and the third is, now let me read this again, 2 more than 7 times the first. 2 more than 7 times the first. So 2 more than, that means we're going to add 2. 7 times the first, well, our first number is x. And there we have our equation, okay? This black marker is a little sloppy, so let me change back here. Let's see, let's go blue. Let's see if the blue one works. Okay, so if we FOIL this, remember, even though this side's factored, the whole polynomial is not factored. Okay, so you got to move everything over and set it equal to 0 first. So sometimes we'll have to FOIL. So x times x is x squared. Do your outside is 2x. Inside, 1 times x is x. 1 times 2 is 2. Okay, now it's just a matter of combining like terms and getting everything moved. So x squared, we get 3x plus 2 equals 7x plus 2. Now notice, if you have the same term on each side of an equation with the same sign, just cross them off. Alright, so I am now going to move this over here. So 7x from 3x is negative 4x. Okay, and that'll equal 0. Alright, now we want to solve this for, or factor this, right? So is there a GCF? You betcha there is. There's an x that we can pull out of both terms. So pull the greatest common factor out front. We still have 1x left in this term and a 4 left over there. So now this is factored. Again, let's use the zero product property. So x equals 0, this equals 0, or x minus 4 has to equal 0. If we add 4 to both sides, x equals 4. So either the first number is 0, 1 and 2, or 4, 5, and 6. So we actually have 2 solutions here. Okay? We actually have 2 solutions. Okay, so one solution is 0, 1, and 2, 3 consecutive numbers, or 4, 5, and 6. So sometimes there's more than one situation that actually works. Okay? Alright, I just want to do one more problem with Pythagorean's theorem. We've done a little Pythagorean theorem this year, not a lot. This would be example 3. Okay, I'm just going to read this to you. And like I said, this is on page 444 if you want to look in your book. It says, Ed and Mark leave the office. Ed traveling north and Mark traveling east. When Mark is 1 mile farther than Ed from the office, the distance between them is 2 miles more than Ed's distance from the office. Find their distances from the office and the distance between them. Okay? So that's a mouthful. I'll have to pull this away to do the problem here. Alright, so one guy is going north and the other guy is going east. Okay, so let's say that they start right here. Okay, this is east and this is north. Okay, so the distance between them, so this is, I think Ed was going north, right? Yeah, so this is Ed and Mark traveled east. So there's going to be a right angle there because the one's north versus east makes a 90-degree angle. And the question mark, how far are they apart as the crow flies? In other words, if you could take a straight line between E and M, what is that distance? Well, you can see that's a right triangle, so we can use Pythagorean's theorem. What we got to do now is figure out what the variables are. Now let me read this again. It says when Mark is 1 mile farther than Ed from the office, the distance between them is 2 more than Ed's distance from the office. Okay, so if Ed's distance is x, so we're going to let x equal Ed's distance from office. I'm just going to abbreviate here. Okay. When they took a snapshot of this, it said that Mark was 1 more mile farther. So if Ed is x, Mark has to be 1 more mile farther. So we're going to let x plus 1 equal Mark's distance from office. Okay, and let me just read this last part again. It says, when they take the snapshot, the distance between them is 2 more miles than Ed's distance from the office. So it's referring back to Ed's distance from the office again. So how can we represent 2 more miles than x? Well, it's got to be x plus 2, right? So the question is, find the distances from the office and the distance between them. Okay, so look, we have variables all over the place, right? And we want number answers. Well, we know the relationship in a right triangle with the 2 legs and the hypotenuse. Remember, the hypotenuse is always the longest side, and the legs are A and B. So Pythagorean's theorem, if you forgot, says that if we take the 2 legs, A squared plus B squared, square the legs, and add them together, it'll equal the area of C squared. Okay? So A squared plus B squared equals C squared. So A and B are the legs. They're interchangeable. So let's call this side A. We'll call this side B. And then the hypotenuse is always C. It's always the longest side. Okay, so let's plug and chug. So in the picture, X is our A. So I'm going to put X in here for A. Our B is the quantity of x plus 1, so make sure you put that quantity in parentheses. That's a group. And C is x plus 2. In fact, let me put the grouping symbols around there. So that equals C, which was x plus 2 squared. Alright, so now we have a good old problem we got to simplify and hopefully factor. Alright, so we got some foiling here, right? Now remember the shortcut when you have a binomial squared, you're going to take the first term and square it. You're going to multiply the two terms together and double. So 1 times x is 1x, but double that, that'd be 2x. And then you take your last term and square it. 1 squared is 1. Okay, same thing over here. Take your first term and square it. X times 2 is 2x, and then double that, that'd be 4x. And then 2 squared is 4. Alright, now it's just a matter of combining like terms, but look what happens. Well, we have 2x squared over here, and then I'm going to subtract that one. So we just left with x squared. I'm going to subtract 4x from both sides. Okay, so we get negative 2x, and then the constant, subtract 4, get minus 3. Okay, and that all equals 0. So make sure, take a second and look at that. I just moved terms around. So this x squared, and what you could do, just cross those off. Might be a little easier to see. Alright, now let's factor. Is there a GCF? I don't see one. Look for that first. Alright, and we're going to have the x here and an x here, a 1 and a 3. Looks like this is the way we're going to go. So x plus 1 equals 0, or, sorry about that, x minus 3 equals 0. Zero product property, right? X equals negative 1 or x equals 3. Okay, well, because we're talking about a distance, we can't talk about a negative distance, right? So this negative 1 doesn't fit in the problem as far as the context, but 3 does. Okay, and I'll let you take a second and check your answer. Okay, check it back up here. Alright, well, that's a little introduction to some application problems. We will do some more in the class, but thanks for watching.